Welcome to this video on the problems of exponents, and in this we are going to try to solve some equations with exponents in them, and all these problems follow a similar method. So the method that we're going to follow is we're going to make this equation such that both the sides are the same base. So we'll have a power something something, and then equal to a power, let's say this something something can be in the form of let's say 2x plus 5 or something, and then a power 3. And then we say that, hey, you know what, for this we will have both the power has to be equal. So what we do is we express both sides of equation with same base and equate the exponents. So that's what we will try to do in all these problems. So let's follow that method in the first one. So it is 9 into 3 power x equal to 27 power 2x minus 5. So this is 9 is 3 squared into 3 power x equal to 3 cube power 2x minus 5. In other words, 3 power 2 plus x equal to 3 power 3 into 2x minus 5. This implies that both your powers or indices are same. So 2 plus x should be equal to 3 into 2x minus 5. That's 6x minus 15, or 5x equal to 17, or you have x equal to 17 by 5. So that's what we mean by express both sides of the equation with same base, and here the same base is 3, and then we equate the exponents, which is 2x is equal to 3 into 2x minus 5. Okay. So let's do the same thing for the second problem. So here's the second one. Square root of 3 by 5 power 1 minus 2x is equal to 17 by 27, and that'll be equal to 4 into 27 plus 17 divided by 27, and that is 125 by 27, that is 5 by 3 the whole cube. That's your right side. Your left side would be 3 by 5 power 1 minus 2x by 2, because that's square root. Square root means, yeah, this is 2. Right, so you have the whole power 1 by 2, and then that becomes 1 minus 2x by 2. That is equal to 5 by 3 power 3. I can write this as 3 by 5 power minus 3 to make these two base same, and now I can equate the powers. 1 minus implies 1 minus 2x by 2 is minus 3, or 1 minus 2x equal to minus 6, or you have 7 equal to 2x, x equal to 7 by 2. That's your answer. Alright, so that's quite simple. So let's look into the next problem, which is this. It looks quite intimidating when you look at it. There's too many things in the denominator, but we need to prove that when you add up all this, that'll add up to 1. Alright, so let's analyze this. So x b minus a is nothing but x b by a, and the next one is x c minus a is x, sorry, it's not x b by a, I'm really sorry, it's x power b by x power a plus x power c by x power a plus 1. That's this whole denominator. So I know that, hey, you know what, this x power a will go here, and I will have I can add up all this. Okay, so I get a hint. So sometimes when you look at the problem carefully, you definitely get a hint. So here's the third problem. So 1 by 1 plus x power b minus a plus x power c minus a is nothing but this is equal to 1 divided by 1 plus x power b by x power a plus x power c by x power a. Or in other words, I can say this is 1 by x power a plus x power b plus x power c, the whole divided by x power a. Or in other words, this is x power a divided by x power a plus x power b plus x power c. So there you go. So we have found out what this is. Now similarly, we can look at the second term, which is 1 by 1 plus x power a minus b plus x power c minus b. By symmetry, we will get exactly, you can look at this and this. Here all we have is, instead of b you have a, and then instead of a you have b, and rest everything is, here also b. So what happens to this? This will be again x power b divided by x power a plus x power b plus x power c, right? And why is that? I would request you to, if you don't really understand why I have written or how I have written based on the pattern, if you have not got it, then I urge you to pause the video and try to do with this exactly what we did in the previous one, and see indeed if you get this. Okay, so similarly, I'm now taking my third term, which is this, which is 1 by 1 plus x power b minus c plus x power a minus c, and that'll be x power c divided by x power a plus x power b plus x power c, right? So you have now three equations, 1, 2, and 3. So if you add 1 plus 2 plus 3, we get this whole thing, right? 1 by 1 plus x power b minus a plus x power c minus a plus 1 by 1 plus x power a minus b plus x power c minus b plus 1 by 1 minus plus x power b minus c plus x power a minus c. That's equal to, your LHS is equal to these quantities, which is x power a plus divided by x power a plus x power b plus x power c, and the same with x power b. You have the same thing here, and then you have one more term, x power c divided by x power a plus x power b plus x power c. So, and this can be further simplified as x power a plus x power b plus x power c divided by x power a plus x power b plus x power c, and that's 1, and so hence proved, right? So that's quite easy. So sometimes the problem looks too complicated, but it really is not. So let's look into the next problem, which is a is given as b power 2x, b is c power 2y, and c is a power 2z, and show that 8xyz is 1. So somewhere I know that I have to if all these quantities I can multiply, then I would get 8xyz. So the question is, how do I get all of this multiplied? So that is a key question. Okay, so you can put in some thought as we start to do the problem 4. You can pause the video and think about it. So let's start doing this. So let's start with a is b power 2x. That's given for us, right? Or I can write it as this is nothing but b is nothing but c power 2y. So I can say this is c power 2y power 2x, and we know that that's equal to c power 4xy. And I have to remove this c, and that we can do by substituting a power 2z. So a power 2z is c power 4xy, and this is a power 8xyz. Okay, so that's your a, and a is nothing but a power 1. So this implies that your 8xyz is equal to 1. So with that, we come to an end to this series of videos on exponents. I hope you enjoyed these videos. I wish you good luck and a lot of fun solving your problems, or from your textbook. See you until your next chapter. Bye bye. Take care.